In this short, you're going to be looking at a minimal spanning tree. So the idea is which path can we use that will give us the least cost. So we can get here by doing everything, and that's the brute force method. So we'd go 3, 5, 2, 15, 2, and then 25, and then compare which is the smallest. That, however, will not scale very well. So what we want to do is use some kind of greedy algorithm, of which there are two, at least the two famous ones. So there's the Kruskal, and then there's Prims. And these are just named after their authors. So let me kind of very quickly start with Kruskal. Kruskal, you start the algorithm by finding the smallest edge. So there we go. So that's 2. Then you go to the next smallest edge, ensuring that you keep the acyclic property. So again, you come and select 3, and then again select the next smallest, keeping the acyclic property. So here, this is the number. So that means we have found our path, and that's how that works. The other one is Prims. So Prims is different. It starts pretty much the same way. So you start with the smallest possible value, which is 2. But then from there, you must ensure that you keep the tree property, which means that the options that you have are either 5 or 15, because that's the only way that you keep some kind of subtree running. So then you can select here. Then the next question is, what else can you select? Obviously, you can select this edge, because then you don't have a tree, you have something that is hanging on this side. And then you look at what's the next easiest one, or the smallest cost, 15 or 3. So we select 3, and just like that, we have found our path. So in this very simple case, you can see that we end up with the same value. Something to realize is, in situations where we have some kind of disconnected graph, then Kruskal will not work very well. And the reason for that is, if we had another graph here, say 5 and 7, and say tying these two was a number like 1, then Kruskal would still jump into that, and that would mean you didn't find the minimum spanning.